Hello, welcome to another session of Grade 9 Mathematics, Chapter 1 Number System. Dear students, today we are going to deal with a new concept called rationalization. Rationalization is a method wherein the irrational denominator, I repeat, the irrational denominator is converted to a rational number. I repeat, rationalization is a process wherein the irrational denominator of a given number is converted to a rational number. I hope this is clear to you all now. If not, let's solve a few questions, examples to get a better understanding. Let us understand the method of rationalization by solving a few questions. Now, over here, let's observe the first number is 1 upon root 2. For here, you will observe that the denominator is a irrational number. So that's where the method of rationalization comes. What we are expected to do is convert this irrational denominator into a rational number. So how can we do that? The first step is to multiply the denominator, the number in the denominator, again with both the numerator and the denominator. So 1 upon root 2 gets multiplied with root 2 in the numerator as well as root 2 in the denominator. If the number would have been root 5, I would have multiplied root 5 in the numerator as well as root 5 in the denominator. But since root 2 is a number, I multiplied it with root 2 in the numerator and root 2 in the denominator. So 1 into root 2 gives me root 2. Root 2 into root 2 gives me the number 2. Let us understand it with one more example. The next sum is 1 upon root 5. Now we proceed with the same step. The number in the denominator is multiplied with the numerator as well as with the denominator. I say it again. The number in the denominator is multiplied again in the numerator and the denominator. So 1 into root 5 gives you root 5. Root 5 into root 5 gives you 5. So this is how you rationalize a irrational denominator to get a rational number. As you can see, the first question was 1 upon root 2. By the method of rationalization, we converted that into root 2 upon 2. The question was 1 upon root 5. We converted that into root 5 upon 5. So the root 5 of the denominator was converted into number 5, which is rational. Do some extra practice by carrying out the process of rationalization for 1 upon root 7 and 1 upon root 11. Let's understand it further with few more questions. Let us take another question from exercise 1.5, question number 5, second one. The question is 1 upon root 7 minus root 6. Now over here, you'll observe that you don't have an individual irrational number. But here, the irrational numbers are in an operation with each other. It is root 7 minus root 6. So in such cases, what is done to get a rational denominator is whatever the denominator is. Here the denominator is root 7 minus root 6. The same denominator is multiplied in the numerator as well as in the denominator, but with a change in sign. So root 7 minus root 6 is the denominator of the question. We multiply the numerator and the denominator with root 7 plus root 6. So what do we get over here? In the numerator, 1 gets multiplied with root 7 plus root 6 and the number remains the same. In the denominator, what we have is root 7 minus root 6 of the first number and root 7 plus root 6 of the second number. Now, what happens with the denominator? If you could observe the denominator, they are actually in the form of a minus b, a plus b. And we have learned this identity in grade 8. A minus b into a plus b happens to be a square minus b square. What is our a? Root 7. What is our b? Root 6. So a square minus b square has to be the solution. So a is root 7, so root 7 square minus b is root 6, so root 6 square. That has been directly written in the next step. We could see root 7 plus root 6 is directly written of the numerator, and the denominator is solved and written directly as root 7 the whole square minus root 6 the whole square. Going to the next step, the numerator is written as it is. In the denominator, root 7 the whole square actually means root 7 into root 7, which is actually 7, minus of the previous step, and then root 6 square, which actually means root 6 into root 6, which is actually 6. In the next step, the numerator is written as it is, and 7 minus 6 happens to be 1. So you can see over here that the irrational denominator has been converted to a rational denominator over here, which is 1. So on rationalization of the given question, the answer is root 7 plus root 6. I hope you have understood this question. In the previous questions, what was different was the denominator contained only an individual irrational number. Over here, the denominator had a group of irrational numbers in some operations. So over here, you'll find the denominator was root 7 minus root 6. It was not an individual irrational number. I hope this question is clear. Let us solve a few more questions so that we are better occupied with the concept. Let us solve the next question from the same exercise 1.5, question number 5, third question, which is 1 upon root 5 plus root 2. Same as in the last question, you will observe that the denominator has a set of two irrational numbers, that is root 5 plus root 2. We'll proceed with the same step. We'll multiply the numerator and the denominator with the number that is given in the denominator of the question, but with a change in sign. So the numerator and the denominator is multiplied with root 5 minus root 2. So in the next step, what we'll write is 1 into root 5 minus root 2 remains the same number. And in the denominator, what happens is we have root 5 plus root 2 into root 5 minus root 2. And this one gets solved, gives you a square minus b square, which is root 5 square minus root 2 square. This is directly written over here. Now, going to the next step, the numerator is written as it is. In the denominator, root 5 the whole square happens to be 5 minus, as it is, root 2 the whole square happens to be 2. So the answer happens to be root 5 minus root 2, the numerator remains as it is, and 5 minus 2 when solved gives you 3. So 1 upon root 5 plus root 2 on rationalization gives you the answer root 5 minus root 2 upon 3. And you will observe that the irrational denominator has been converted to a rational denominator over here with the number 3. Kindly practice one more sum the same type. Here the question is rationalize 5 upon root 5 minus root 3. Let us get to the next question of the exercise. Now, the last question of exercise 1.5, question number 5 is the fourth one, which says that 1 upon root 7 minus 2 is the question. I repeat, we are expected to rationalize 1 upon root 7 minus 2. Kindly observe that here only 7 has a root sign. 2 does not have a root sign. But the method remains the same. We have an irrational denominator. So what we'll do in the next step is multiply the numerator and the denominator with the numbers that are present in the denominator of the original question, but with a change in sign. So the question had root 7 minus 2, but to get to the solution, what we'll do is multiply the numerator and the denominator again with root 7 plus 2. In the next step, you will observe that the numerator, which is 1 into root 7 plus 2, remains the same since it is multiplied with 1. The denominator actually gets solved, and using the identity a minus b into a plus b, which gives you a square minus b square, the denominator, which is root 7 minus 2 into root 7 plus 2, can be written as root 7 the whole square minus 2 the whole square, which is a square minus b square. That has been directly written over here. Now, you can see in the next step, the numerator is written as it is because root 7 plus 2 cannot be added. They are unlike terms. And in the case of denominator, root 7 the whole square is actually 7 because root 7 the whole square is root 7 into root 7 minus, as it is, 2 the whole square is 4. So 7 minus 4 happens to be 3, and the numerator remains as it is. This is how you will actually proceed with the process of rationalization and convert an irrational denominator into a rational denominator. Also practice another sum, which is rationalize 1 upon 2 plus root 3. I hope by the end of this session, you are clear with the method of rationalization and will do better in the exams. Kindly practice all the given questions. Take care till then. We meet for the next session. Thank you.